Hello and welcome to this video for my final project for electronics. I'm doing an inverter with 3-phase using Simulink. So this is just the MATLAB file where I can control the initial parameters we can simulate. So on the first part, for example, my voltage was 800 and you saw when I change it to 500, the power lowers down, the voltage and the current lower down because the amplitude modulation is not enough to keep the power that we're looking for. So I created a controller and a boost inverter on Simulink. This is what I've been working on. So this part is the source that goes into the inverter, but before the controller. We also have the pulse width modulation logic. We have our IGBTs, and this connects to our three sources, the 250 rated sources that are in parallel, and these are the scopes. So we have input voltage scope, switching waveform plots, output voltage, and then the ripple voltage. We also have the battery backup. I'll spend more on it later. We have the three-phase total voltage scope. The only difference on this side is I have a controller, so it's everything that's on the left. We have a boost inverter. This is the actual voltage. That's the input for MATLAB. This will increase the voltage. And then I also have a relay right here. So depending on the amplitude of the voltage, I can decide to send it to a battery backup, which would be this circuit, or to send it to the main circuit, which is just like the actual inverter. And this is the actual controller. So I saw many people use the PID, but I just couldn't figure it out. So right here is the closed loop. I have some switches. I have an actual saturation cap. I also have a slope, a ramp slope, and I also have a memory. So what this does is it analyzes the amplitude voltage and it determines the starting point. So we can start either from 0 or we can do an actual calculations to not waste so much time. And the thing that we'll do is add a little bit of the ramp to the amplitude modulation, to the pulse width modulation generator that will go from here to the MOSFET in the boost bus. So once it's already the parameter that I already want, it will stop and it will latch to the second switch and it will stay over here. To do that, I also have this relay, and in this relay I have the variable that I was working on limit. This was determined experimentally. It depends on the range. So let's see how it goes. So if we run it, we should get an output, and I will share it after it's done compiling. See how the voltage right now is switched on the second part, because this is the initial value, and see how my ramp is adding a little bit to the control modulation. So this is like having a PID, but not really with a PID. With a PID, you can, in my case, I couldn't tune it on real time, but this auto-tunes itself on real time. But that's why I have the ramp, and I'm having the feedback on the left, and I'm having the relay to cap it off to the output that I want. But I'll explain more on it later. And we see, for example, right now it's a 0, so the relay output right here, it's controlling it's multiplying to a 1. So in this case, the output is going right here. And you can see how, for example, our backup battery is at 0, so everything's flowing into the loads. We have our continuous RMS or continuous current, and we have the power that we want. These are the ratings that I had for 800 voltage back on the first side when all the conditions were perfect. But now with the boost block converter, I can input those 500 volts and actually get what I want. So let me pause a little bit and I'll show you the scopes. So first, this is the scope for the input voltage. So the thing is the relay has some actual control. So see how it's like a PID step response, and it starts, and then this is how the ramp is starting to add into the pulse modulation, and until it gets to the 800, more or less 800 volts. And see how it has very, very, very small ripple because the design is not with a PID. And I can talk more about ripple later. Here we also have the switching scope. So this is how the sign is compared to the actual sawtooth, and we get the switching pattern and the not switching pattern. So this is more on the inverter side rather than the controls, but it's just the scope that I also like. This is the scope of the sinusoidal for each of the 3 phases. Of course, this is not sinusoidal. I will explain it more with the filter, just how I did on the first part that is on the report. but you can see how the switching, it has a little bit of ripple, but it's actually not that bad. And I'll talk more on the ripple. I also have a scope specific. These are the currents. See how also I have ripple, but it's actually like not so bad. It's actually really, really good. And the current, this is of course non-sinusoidal, but the ripple is also really good on the current side. Talking more about the ripple, the top one is the voltage ripple for the load, for one of the loads, but both loads will be the same because the radial is the same, and I have like on the measurements is the same values. And the bottom one is the current ripple. See how at the beginning it like takes a little bit, it has a little bit more ripple, it's a little more non-uniform, but later on, like after like a couple cycles, it smoothens out a lot. So you can see right here that the ripple on the load side is actually pretty good, and that's a measurement that I like a lot about my control. Finally, as I promised, this is like the actual sinusoidal voltage on the load. I used a little bit of a filter. I used a filter just like in the first part to get this scope to work, but I don't play around with the capacitor values anymore. It's actually working pretty good. Okay, so finally, this is like for the sinusoidal. Notice how I have like a low pass filter for the sinusoidal, because like before I had it just like the hard switch, how I have it, but I'll show you the scope once it's like once I have it, is the sinusoidal for the three. So this is the three-phase sinusoidal on the filter. See how it's like the sinusoidal has a little bit of an edge right here, but overall the three phases are actually like pretty good themselves. This is like everything together. So if we extrapolated that a little bit and separate them, we can see the sinusoidal a little bit better in shape. Each one individually is per phase, and see how the sinusoidal is like a little bit sharp, but it's actually the form is actually really good. I was really impressed with the control. Going back to the controller, you can see how right here, like the actual value switched to the second latch, and right here I have a memory, and it's the last value that's going to the MOSFET that's modulating the boost, and this actually works for all the values. So imagine if you had like 500 or even 440, and 440 volts is actually gonna have the same behavior. The only thing that will be different, it will be like if I put a value that's below 350. In that case, I don't have like it's the actual limitation of the boost inverter, and the actual amplitude modulation is like a little bit lower on the voltage side. But what we could do is send it to a battery backup, and I could explain a little bit later. So the difference here is, like, the controller is still the same. You know, I have it already latched the pulse width modulation index right here is already latched, so it's already set and saved. The only thing that's different is, see how on the previous side on the main relay had a 0 on, so now it has a 1. So right here, if it comes in at a 1, and then you have the NOT gate, it makes it into a 0. So the V out that's going inside here, see how all my values are 0. But on the battery backup, because the relay is at the 1, like I'm just like simulating how you can have it as a battery, because see how the output is gonna like peak at 555, and I can show you on the scope a little bit when it's done like simulating it. So when it's already done, like I have like 560 volts, which is not ideal, because if I put 560 volts, I'm gonna get like very like the power that I was getting on the first time. When I had like the 500, I'm gonna get a lot of losses, almost like half losses. But in real life, what you could do is use like this battery backup. So as the threshold will be like those 350 volts, which is not ridiculous. It's like less than a half of the 800 volts, which is like something that would happen on the PV side. The thing is, right here, I can simulate like how the battery backup will look like. This is the scope that I have. So see how it like shoots, but it has no overshoot. Like the controller is like super. It has like a really smooth shape to it, and then also like we have very small ripple. That's actually like behavior that's desirable in a battery backup, and not only because like the limitations of the equipment are already there. So if you have a capacitor bank or a battery backup, you can actually not throw all that voltage to waste, but that voltage is not gonna be good enough to generate the power on your three-phase load, but you can actually save it right here. Something that so yeah, that was the last part of my project. Like in reality, I can change the actual like voltage to any input that I want. Like in this case, I only have a hard variable in MATLAB that I send to the very initial voltage over here. But the control is actually something that I was really impressed with, because like you don't have to auto tune it. Like you can make all of this equipment into like a PCV control that is attached to the boost inside a house, and you can actually like have it running itself. Of course, there's like a delay of like a couple of cycles each time, but it's not really something that is bothering me, because like for example, I simulated here in 3 seconds, and by like half a second it's already like the system is already in the steady state level. That's something that is actually really good in real life, and this is like the model that I'm proposing on my project. And of course all the like actual plots for all the values will be on the actual report themselves, but like I will welcome you to put my MATLAB values and change them yourselves, and actually play with the model itself, and it has the scopes with all the titles in them. And that will be it for me. Thank you.